Okay, so this, guys, is the fourth video dealing with acid-base equilibrium. Three of them have dealt with buffers, one of them with strong acids and strong alkalis, calculating the pH of that mixture. Okay, so this is how to calculate the pH of a buffer made by method number 2 of making a buffer. So if you remember in video 2 we spoke about how to calculate the pH of a buffer made directly from the weak acid and the salt of weak acid. In video number 1 we looked at how to make a buffer from the salt of weak acid and a weak acid, but we also looked at how to make a buffer between an excess weak acid and a strong alkali. Now this video here deals with how to work out the pH of that buffer made by an excess weak acid and a strong alkali. Okay, so video 2 shows you how to work out the pH of a buffer made in the other method of a weak acid and the salt of the weak acid. Okay, so get those two different methods clear in your head. If you need to revisit videos 1 and 2, well then perhaps you might want to do that. Okay, right. So we're not going to look at the theory in this video on how this weak acid in excess and the strong alkali actually behaves as a buffer. That was covered in video 1 and I'm not going back over that again. This is purely to work out the pH of that. Okay, so let's have a look at how we do this, and video 3 would be quite important in terms of having looked at the interaction between an acid and an alkali in terms of that also. Right, so let's have a look how we do this. So we're going to calculate the pH of the following buffers. Okay, so I have a few worked examples here. I'm going to talk you through them, and there are several of these again in your class notes, and there's if you need any more, I have a worksheet of my own which you can have. I've probably given it to you anyway. Okay, so we're calculating the pH of the following buffers. So example number 1, we have ethanoic acid. So it would be a good idea just to sort of label these as we go along. So that's, of course, that's my acid, and it should be in excess. Okay, in order for it to be a buffer. We have potassium hydroxide, which is of course my alkali, and we make potassium ethanoate. That's my salt. And we remind ourselves what a buffer is. The buffer will be the acid and the salt of the acid. So we've got concentration, we've got volume of our acid, and that gives us that number of moles of the acid. Initial N stands for number of moles. Okay, 0.15. If I go to my alkali, I have concentration of 0.3, a volume of 300 centimeters cubed, and I have got therefore number of moles 0.09. Right, so clearly my weak acid is in excess. These react in a 1-to-1 ratio. We can see that. If I have 0.15 moles of the acid and only 0.09 moles of the alkali, my alkali is my limiting reactant, okay, and my acid is in excess. So that means that all of my alkali will react, and at the end of the reaction I have no moles of alkali left. My moles of acid that are left are 0.15, which I started off with, minus the number of moles that will react with the alkali, which is 0.09 of course, gives me 0.06 moles of it left. Okay, now remember, to work out the pH of a buffer, I rearrange my equation, and remember it's a buffer, to H plus equals Ka times the concentration of the weak acid over the concentration of the salt. Okay, so my volume that I've got, that my moles, my 0.06 moles of acid are in here, my volume is the two 300s added together, of course 600 divided by 1000 gives me 0.6 of a decimeter cubed. So my concentration of my acid is 0.06 divided by 0.6 is 0.1. Okay. My salt then is determined by my limiting reactant, which is of course my potassium hydroxide. So my moles of salt they're made, 1 mole of salt is made per 1 mole of potassium hydroxide. So I have 0.09 moles of salt made. Again, it's in the volume of 600 cc's. So my concentration of it is C equals moles divided by volume. So moles is 0.09, volume is 0.6. That's my concentration of my salt in this instance. I put that into my equation from up here. So my Ka will be given you in the equation. That's what it is. I haven't given it to you in the equation here, but put it in there, is the Ka multiplied by the concentration of the acid, the Ha, divided by the concentration of the salt, gives me this 1.16 10 to the minus 5. That's the concentration of the hydrogen ions in here. I minus the log of that, and I get 4.94 as the pH. And that's sort of around where I would expect. If you're getting anything sort of between 4 and maybe 6, you should be in the right ballpark here. If you're getting outside that parameters, you maybe want to have a sort of a review of your answer. Okay, we'll do one more here. I think these aren't too bad. Okay, so again, the only difference that I have here, and maybe you might want to pause the video and do this and check your answer against what I have here. That might be a good idea. Anyway, I'll talk you through this. If you're not confident enough to do them yourself, you can go and do some in your notes yourself. The only difference here is this time we've been giving you mass of the acid and the alkali, so you're going to have to use number of moles equals mass over the RFM, which is what we have done in this step, which is what we've done in this step here. So we've got 0.25 moles of the acid, and again we've done the same here. We've got 0.1675 moles of the alkali. There's my volume there. They're mixed, so just maybe remind yourself that that's going to be 500 cc's, or in other words 0.5 dm cubed. Okay, right, so to begin with, my moles N, remember N's moles, initial is 0.25 moles of the acid. I had 0.1675 moles of the alkali, so my acid is of course in excess. My alkali is my limiting reactant. It'll limit how much of my salt I can make, and therefore the moles of acid that is left over will be the moles that I started off with minus the moles of alkali that it reacted with, which gives me 0.0825 moles of it. I want concentration of it, so I divide that by the 0.5 from up here, and my concentration therefore of my HA 0.165. I pop that into my equation that you should know off the back of your hand by now. Okay, I go and deal with my salt now. So the moles of salt that will be made, because they are in a 1-to-1 ratio and the alkali is my limiting reactant, it'll be the same as the alkali. Again, I have my 0.5 to get that into concentration. Gives me a concentration for the A minus the salt as 0.0335. I pop that into my equation down here. Okay, I get my hydrogen ion concentration of 8.57 times 10 to the minus 6 here. I minus the log of that, and that gives me 5.07 of a pH. And again, that's within the sort of the reasonable parameters for an acidic, a weak acidic buffer. Okay, hopefully that allows you to see, guys, how you would make, or how you would calculate the pH of a buffer made by an excess weak acid and a strong alkali. The key thing about all of these is read the question, make sure you are answering if it is a buffer question or is it just a question where you are looking to calculate the pH of a acid and an alkali mixed together. Okay, there'll be clues in there, or it might just tell you directly that it is a buffer or it is an acid and an alkali reacting together. Okay, again, there's lots of questions in your notes and in the calculations textbook, and I'm sure we have spare ones if you need extra help. Okay.